Okay, so we've been given an equation of carbon plus oxygen gives carbon dioxide. This value here is telling us that there were 393 kilojoules of energy released. So it says, the first question says what mass of carbon must be burned to produce 2,556 kilojoules. So our known is the amount of energy, and our unknown is the carbon itself. So I'm just going to rewrite that. So 1 mole of carbon will produce 393 kilojoules of energy. So this is our known and this is our unknown. The same as we've done it previously, the number of moles of carbon will equal our unknown over a known, and in this case what we know is our energy. So our unknown is 1. Our known is the 393, times it by the energy that we know, which is 2,556, and this comes out to 6.5038 moles. Now from there we need to calculate the mass of carbon. So we know the mass of carbon is equal to number of moles times formula mass, which is 6.5038. times 12.01, and this comes out to 78.11 grams to 1, 2, 3, 4 significant figures. Let's try the next part. It says what mass of oxygen is required. So from this equation you can see that 1 mole of oxygen releases 393 kilojoules. So this is our unknown and this is our known. So the number of moles of oxygen will equal unknown over known times the energy that we know about. So it's going to be equal to 1 over 393 times 2,556. This will come out to, once again, 6.5038 moles. Finding the mass of the oxygen is equal to number of moles times formula mass, which is 6.5038 times 32, and this comes out to 208.1 grams to 4 significant figures. It says now what volume of oxygen at STP. Well, we've already got our moles, so we know the volume of oxygen will equal number of moles times 22.71. In this case the number of moles was 6.5038 times 22.71, and that comes out to 147.7 litres to 4 significant figures. The last question is what mass of carbon dioxide is produced. Well, we can see that 1 carbon dioxide produced 393 kilojoules. So this is our unknown and this is our known, same as previously. So the number of moles of carbon dioxide will equal unknown over known times the energy, which we do know, which was 2,556. So 1 divided by 393 times 2,556 will once again come out to 6.5038 moles. So the mass of carbon dioxide will equal number of moles times formula mass, which is 6.5038 times 44.01, which comes out to 286.2 grams to 4 significant figures.